Design principle. Okay, so if there are 23 design patterns, then there are 5 design principles. So it starts with it is solid. Okay, SOLID, single responsibility. Okay, and then O for open close, and L for the scope substitutes, and I for interface I for interface segregation, and D for dependency inversion principle. So we start with the open close, then the scope substitution, dependency inversion principle, and then followed by interface segregation. Everything we have. What is remaining is the first one, and knowingly, unknowingly, luckily, unluckily, it is the most important kind of uh, design principle. So we're talking about single response. If people know machine learning, then in machine learning we have samples. Each sample has components. It is also called feature. Like if I have a sample in 3D coordinate 2, 3, 4, then its component in X, Y, Z direction is 2, 3, 4. So like that, there are samples and they have components in n direction. So samples are m, and samples if samples are n, then samples are n, then there are m features. So n into m are the total entities. Now we have kind of now the each sample with a set of features, then there is a class. Class in the sense what where it belongs to. Okay. Now if I have two set of class, if I have two class, now inside one class we have set of samples with features. We have set of samples with features. Now, intra-class, inside the class, all the samples should be cohesive. Cohesive in the sense that their nature, their okay, kind of a correlation, okay, covariance, correlation, okay, reason to change, okay, so that among the feature inside the class should be one single. Now in other class, reason to change, okay, if I say a reason to change in the sense that I go sample by sample, this is how we are changing, or feature wise it is changing the way. The reason to change inside a class, intra class, it should be unique inside a class. So intra-class should be cohesive, whereas inter-class, it should be as far as possible. So it should be as good as it should be orthogonal. But inside the class, okay, samples should be cohesive. They should be near to each other. So generally, what we modify the database. It's not that we don't modify the database, like LDA, linear discriminant analysis in machine learning, where whatever is inside the class, so we make it stick together, and interclass we make it go kind of wider. So this kind of design principle, where a class, inside a class there is a single reason to change. If a class is changing, data is changing, or whatever is changing, there should be a single reason to change. Like machine learning, machine learning has so many classes. Inside each class everything should be cohesive, whereas inter subclass things should be separate. Okay, that way inside a class all the methods, all the functionality should be cohesive. There should not be a two party two party system inside a class, or multiple party system in a class. So this is single responsibility. We have given responsibility to a class that is a single responsibility. Okay, so now consider the kind of printer class. Printer class collects document and prints it. Simple, but there is a problem. collection of document is independent of printing it completely. Collection of document has nothing to do with printing it. They are orthogonal. The set of methods that comes under a logical unit collection of documents and set of method logically comes into the collection of into the method collection of methods in printing are different. They are orthogonal. They don't know each other at all. Why they should be in a class? A class should carry single responsibility. There should be a single region. Like we saw interface segregation, where a client who has written code based upon a class, like we talked, a client has written code based upon the I printer. An I printer has many things like sending email itself, it has Bluetooth, and email means sending communication document to the printer, email, Bluetooth, and probably others can be. A client who does not know anything about Bluetooth, he should not be forced to see Bluetooth APIs method. Okay, so that is interface segregation. I have to change the interfaces and in a way that this client would pass the email email object against the communication interface that about we discussed. Okay, so he doesn't know anything about the Bluetooth. Similar fashion in single responsibility principle. Okay, a class cannot be forced to do two different things. A class cannot be changed with two reasons. Okay, now if I have something to do with the printing, then one set of methods will change. So cohesion in one area, clustering in one area, then another clustering area collecting the document. So there are two reasons that printing class would change. Now it's a good idea that we separate these two as separate. Okay, printing separate classes, collecting documents separate classes. More nicely, two different interfaces. More nicely, anyone can implement these two, yeah, realize these two interfaces, or two guys can realize these two interfaces. Then beyond that, we can think that we can go for we can go for a dependency inversion. Can you see that queen of the design? But anyway, everything is based upon open close one. Open close followed by Liskov substitution and then followed by uh, dependency inversion. But dependency inversion is something that is kind of crackable. Okay. Now, in single responsibility principle, we have two reasons a class can change: collecting a document, and then we have a reason that it should change because it is printing it. Now, two separate classes or two interfaces, one can realize it or two can realize it, and those two interfaces now go as they will become a dependency for the client who is depend upon it. So client who is calling the printer class, now he depend upon only two interfaces. Okay, these two interfaces now will be kind of realized by two separate class or one class. But client has no reason to be dependent upon single interface or single class. So both sides clean with design pattern would kind of implement it. So I would rather say command design pattern. Surprising. Anyway, strategy is always there when we create algorithm and strategy, but command design. Command design pattern where a class carry different operation, they're nice to put operations in separate class. Like robot. Robot has method move forward, move backward, move left, move right. Nice to derive from the robot. And have four robots move left, forward, robot left, robot right, robot forward, robot backward. Now, robot forward, if I call a function called execute, I know it will move forward. Rather than calling separate function differently, because they all do different things, different movement is there. If that is the case, then all four robots now which has predefined movement, we can place in a queue list and we can just say execute, execute, execute. So 10,000, if I am sending robot on Mars, okay, then I can just pass a series of commands and those commands will be executed against the specific robots they are placed in the queue and they would just execute and it would move in that fashion. So this is a kind of, or more way, better way we can say that there is a robot. I think it's all right. I won't go more complex in it. So command design pattern where we have each class is getting a kind of each operation against an object is getting a responsibility status of the class, and then we give each class a single responsibility. So that is the status. So why to wait and start using single responsibility principle, then open close principle, then Liskov substitution principle, then interface segregation and dependency inversion. Solid. So become solid.